Welcome back everybody, and today's video is about limits. So this is an introduction to limits, so I'm going to be using an algebraic approach to solve these limit problems. In part 2 of the video, I'll go on to L'Hopital's rule and use the differential approach to solve certain limit problems. This features in the AP Calc course and also the IB standard level and higher level. So what is a limit? Well, if you think of a function, and we have one here, imagine plugging values in closer and closer to a certain point. But we can't actually put that value in. If we do, there could be an undefined point. So look at the graph on the left here. We can see that we will not be able to substitute 0 into this function, because if we do, it will create an undefined point. In this case, we'll have 0 over 0, which is an undetermined function. Therefore, then there is a missing point here at the point where x is equal to 0. So what do? Well, consider if we are plugging values in closer and closer and closer to that point. So we will be able to substitute a value of x into this function, and we'll be able to read off a value of y. As we get closer and closer to that point, we'll get a reading that is closer and closer to 5. So really think of it as a limit being what a function's value gets closer and closer to as you pick inputs nearer and nearer a certain point. It's like guessing where a path is going without actually stepping on that spot. If we go down here and we have a look at the first 3 examples. So we're going to use direct substitution here. This says, what is the limit as x tends to 2 of this function? Now, when you see a function like this, if you're able to substitute the number in and there is no undetermined point, then you can just go ahead and use what's called direct substitution. So when we substitute 2 into this, we would get 2 squared plus 2 times 2, which is 4, so that's going to be 8. So the answer to this question is just going to be simply 8. Now, let's go on to part 2, or B. So what is the limit as x tends to 2? Now, again, we can see that we can substitute 2 into this, because 2 on the denominator will not create a 0, so therefore it'll actually be over 4, but 2 minus 2 will be a 0 on the numerator. Now that's okay, you can have a 0 on the numerator, because 0 divided by anything is just 0. It's when the 0 is on the denominator that we need to delve a little bit deeper. Okay, and I just drew another one here. What happens when we substitute 0 into this? Well, we need to know a little bit about indices here. We'll recognize that this is written as 1 over e to the x. And when we substitute 0 into this, what we actually get is 3 minus 1 over e to the 0. Now, anything to the power of 0 is just 1. So therefore, it'll be 3 minus 1, which is 2. Okay, so the limit of 3 minus e to the minus x, as x tends to 0, will be 2. Let's go on to factorising. So in these cases, you'll recognize immediately that we cannot substitute this value 0 into this one, because we will have a 0 on the denominator. So what do? Well, if we are able to factorise, we factorise, and we'll see that some terms cancel out. So I can take out a factor of x. So x plus 3 over x. And when this happens, we can just cancel like we've done in all the other parts of the course, leaving us with x plus 3. Now, if we are able to substitute this 0 value into this, and we don't get an undetermined point, then that is our limit. So when we substitute 0 into this, we will just get 3. So the answer to this problem is just 3. What you can't see from the graph is that there will be a hole, like an undetermined point, when x is 0. So if I just go ahead and circle that, that will be here. This point actually doesn't exist on the graph. So it's continuous on all other parts of the graph, but it's discontinuous at that point. Okay, as you notice when you graph it, you can't actually see that. So that's why I wanted to provide the graphs, just to show you. Here we see that we cannot substitute 3 into this because the denominator will be 0. So we are going to do the same technique as we did on the first one, is that we are going to factorise. So this will be x minus 3 and x plus 3. It is the difference of 2 squares. And we can see that one of these brackets, one of these parentheses, cancels with 1 on the denominator, therefore leaving x plus 3. So therefore now we can substitute 3 into this expression, because we are those two things have cancelled. So therefore then we would just have x plus 3 remaining. So 3 plus 3 would be 6. So the limit of this expression, or this function, is actually 6. So remember, that's the number that we're tending closer and closer towards, but it actually is a discontinuous point on the graph. Okay, this one is a final factorization, and you've seen the techniques now. We'll need to factorize the numerator, and we can see that this is going to be a quadratic, so we're just going to factorize that, okay, using our techniques from factorization, and we can see straight away again that this cancels with this. Now I'm left with one parentheses, and then there's no issue substituting 3 into that. So when we plug 3 in, we get 3 plus 2, which is 5. So the limit of this function is 5. Okay, let's move on to the next technique. Okay, so the next type that you would encounter is fractions. So we can see straight away that we are not able to substitute 2 into this because we'll get 0 on the denominator. We can see from the graph that there is going to be an answer because we have the value here, which is 2, and this will read off on the graph. However, it is an undetermined point at that location because we can see that when we substitute 2 in, there's an undefined point there. So what do we do? Well, there is a technique that I use, and we are just simply going to multiply the two denominators of these fractions here. So that's 2x. Now, if we times top and bottom of this fraction, so the numerator and denominator, by 2x, this will help you solve this style of problem. So 2x times by 1 over x minus 1 half, all over 2x times x minus 2. Okay, so I have multiplied numerator and denominator by 2x. Now I'm going to multiply out. Okay, so therefore we will get 2x over x, which will just lead to 2, minus x. Okay, so I'm multiplying out using FOIL. On the denominator, I will not times out, I will leave it like this because we can see in a moment, with a small adjustment, I can actually cancel out these fractions. Okay, so if you look here, this is 2 minus x, and this is x minus 2. There's a very simple fix for that. What I can do is I can just take out a factor of -1 on the numerator. When I do that, I will get x minus 2. Okay, if you times back in, you'll get minus x, and then plus 2, which is exactly what I started with. But now, what's good about that is I can now cancel with the value, like the parentheses on the denominator. So it's a very quick technique, leaving me with minus 1 over 2x. Okay, now if you are able to substitute 2 into this, which I can, and it doesn't create 0 on the bottom, then that's what I'll do. So I'll substitute 2 into this. 2 times 2 is 4, so it's negative quarter. You can't see from the graph there, but that would actually be minus 1/4 there. Okay, so that's our technique when we have fractions. Okay, so this style of limit problem involves a radical. So what are we going to do? Well, the best approach here is to use what's called the conjugate. So we look at root x minus 2, and the conjugate of that will be root x plus 2. So I want you to times numerator and denominator by that conjugate, which is root x plus 2. And this is a technique that would help us solve this style of problem. So when we do that, we can now multiply out. So root x times root x will just be x. Then we'll get 2 root x minus 2 root x minus 4. Okay, now on the denominator, we will have x minus 4. I'm going to leave it in factored form, and then root x plus 2. So I haven't done anything with the denominator. Now in the numerator, you'll see that the 2 root x and the minus 2 root x cancel each other out, leaving us just with x minus 4 on the numerator. Now that is exactly the same as one of these factors on the denominator, so we're going to be able to cancel that out. So cancelling x minus 4 and x minus 4 leaves us with 1 over root x plus 2. Now we go ahead and we look back at the limit, and the limit was 4. Can we substitute 4 and not get a 0 on the denominator? Yes. Okay, so when we do that, we'll get 1 over, that'll be 2 plus 2, which is 4. So the limit of this question is 1/4. In this example, we use a combination of the last two examples. So we have not only fractions, but we've also got radicals involved. So what we're going to do is we're going to use the same techniques as in the last two examples, but we're just going to have to do them in that order. So we're going to basically look at the common denominator of these, and that's 2 root x. So I want to first of all times numerator and denominator by 2 root x. So when we do that, we'll have 2 root x times by 1 over root x minus a half. So 1 over root x minus a half, and that's all going to be over 2 root x times x minus 4. Okay, so now we're going to multiply out and put down our result. So when we multiply out, we're going to have 2 root x over root x, that should be 2, minus, and the 2's will cancel on this time, leaving us with minus root x. Okay, and that's all going to be over 2 root x, x minus 4. Okay, now we're left with the radical. So if you just recall from the previous example, what we're going to do is we're going to multiply by the conjugate of this. So when we multiply by the conjugate, we can actually just times by 2 minus root x, we can multiply by 2 plus root x. Okay, and we're going to do the same with the denominator. So currently we have this, and now we need to multiply by 2 plus root x. Okay, so we've times numerator and denominator by the same thing. Let's multiply out this. So we have 2 times 2, which is 4. Then we get plus 2 root x minus 2 root x. That's great. They're going to cancel out. Then minus x. So that is all over 2 root x, x minus 4, 2 plus root x. Okay, so now we have these expressions here just cancelling, leaving us with 4 minus x on the numerator. Now on the denominator, we have something very close, and if you remember from a previous example, what we can do is we can take out a factor of minus 1 on the numerator, so one of those expressions will also cancel. So what I'm referring to is this here. We can take out a factor of minus 1, making that x minus 4, okay, and that's all over 2 root x. Then we have x minus 4, and then 2 plus root x. Okay, now that will cancel with one of those. So the more that you can cancel out, the better. Makes it a lot more simpler when we're substituting the value in. So now we have the following. Okay, now we have a 1 on the numerator, and if we're able to go ahead and substitute a value in now and not get 0 on the denominator, we are done. So we have to substitute in 4. So when we substitute 4 in, there will not be 0 on the denominator. We will be left with, well, 2 times root, so that will be 4. Then we have 2 plus root 2, so that's also 2, leaving us with negative 1 over 16. As I said earlier in the video, in part 2 of the video, I'm going to explore L'Hopital's rule. So in L'Hopital's rule, we'll use differential calculus in order to solve it, but we can only really do that if we have the form when we substitute the limit in of 0 over 0 or infinity over infinity. So we'll use differential calculus, and please join me in the next video as we explore that. Let me know how you get on in the comments below. Don't forget to like and subscribe to the channel. See you next time.